You are welcome to my channel. Thanks for visiting. Today, I'll be going through some common lab valves when it comes to renal system, which some people will know simply as kidneys. I'll talk less, but be showing you some valves. Without further ado, let's go. Let me quickly tell you that different labs may have different valves, but all the labs will put down the expected range. The disparity is as a result of different methods used and different gadgets used. When it is about urinalysis, you first of all consider the volume, but the volume will be based on your intake, the weather condition, whether you are sweating or sweating profusely, and whether you are on certain medications that could retain fluid or certain medications that could send out more fluid, and some other conditions like obstructive uropathy. Now, maybe you have prostatic carcinoma or benign prostatic hyperplasia, now obstructing the flow somewhere, or ureteric stricture, anything, or even fluid being lost into the third space. All these things, or you are even vomiting, all this will determine the volume per day. But normally, if everything is normal with you and you are taking fluid the right way, you are expected to be producing between 800 mils to 2 liters per day. A majority will settle for 1 to 2 liters per day. The color is expected to be pale yellow or dark amber. The odor should be mildly aromatic. We don't expect it to be fruity or of acetone. If we pick that, then we have to investigate further as per diabetes mellitus. Now, the pH. Ketone should be negative, but when it is positive, you might be lucky that it's only as a result of fasting or starvation, but it might be as a result of diabetes mellitus. Specific gravity and glucose should be nil. That might be okay within 1 to 20 milligrams per day. The reason is physiologically, the transport maxima of the kidney might be exceeded based on the glucose content of whatever you've taken in. And that is the strong reason why we do not make the diagnosis of diabetes mellitus based on urinalysis alone, because it might just be because the transport maxima has been exceeded and nothing is really nearing diabetes mellitus. So when glucose is peaked in urine, we'll think, okay, it might be as a result of the intake, transport maxima exceeded, and part of this glucose has been sipped into the urine. Correct. Is it diabetes mellitus? We'll have to do more. Let's get the serum. What is the value there? Hemoglobin A1C and some other investigations. Serum anion gap. Urinary anion gap is of less importance. Urinary calcium in 24 hours urine will give us this value for female and this for male. You can always pause and have a look. Urobilinogen, bilirubin, VMA, that is vanille mandelic acid. In urine, it's not expected to be large. It should be less than 9 milligrams per day. And this could be pointing to pheochromocytoma. I mean a value that is high, right? Be pointing to pheochromocytoma, neuroblastoma, physical exertion, emotional changes, so many medications, including clonidine, morphine, caffeine, lithium, insulin, and many more. HVA is homovanillic acid. It's expected to be as low as 0 to 15 milligrams per day in anyone 18 and older. But we usually express HVA to the ratio of creatinine excretion. An example would be as low as 0 to 8 milligrams per gram of creatinine in anyone 18 and older. Now, 5-hydroxyindoacetic acid is pointing to serotonin breakdown or carcinoid tumors, and the value is expected to be as low as 2 to 9 milligrams per day. Red blood cells, 0 to 3, high power field. Red blood cell cast, white blood cell cast, negative. Hyaline cast, 0 to 2, granular cast. Waxy cast should be negative, but when it is positive, it means the kidneys are very bad. Fatty cast should be negative, but it could be positive in diabetes mellitus microvascular complications with nephropathy. U cell should be negative. When it is positive, might be pointing to renal tract infection. Nitrites will be expected to be negative. When it is positive, it's pointing to bacteria, but there may be bacteria causing urinary tract infection, and nitrite could still be negative. So, negative nitrite is not ruling out the presence of bacteria. Epithelial cells, 1 to 5 squamous cells per high power field could be accommodated, while 0 to 3 renal tubular cells. Blood urea nitrogen, 1.8 to 7.1 millimoles per liter serum plasma. Uric acid in urine, uric acid in serum. Urea nitrogen in urine. Like I said, you can always pause. Fractionated urinary metanephrines in 24-hour urine. Find this value for metanephrine and metanephrine. Urine catecholamines dopamine. Epinephrine, norepinephrine. Creatinine, mostly from blood sample, for male and for female. The urine creatinine will give us this for male and for female. You can always pause to have a look. Now, to estimate creatinine clearance in a female, I've decided to make this mathematical calculation here. Creatinine clearance is 140 minus h in years times the weight in kilogram divided by 72 times serum creatinine in milligram per dl, and in a female you add multiply by 0.85 again. Now I've given an example here. A female, 50 years, weighing 70 kilograms, with serum creatinine at 6 milligram per dl. So putting all those figures right here, we'll get this. Okay? So the 140 minus h times 70 will give us this. Okay? Then 72, which is now a constant factor, times the serum, which is 6. 72 times 6 will give us this. Then, when we divide this entire value by this, we'll get now 14.58. Then that 14.58 times 0.85, which is a factor for females, will give us this as the final result. If we are dealing with a male, we don't need 0.85. We just multiply by 1. So we don't multiply at all, right? Because it's still going to give us the same. So the value will be a little bit higher in male. So the final answer on this page is 12.4 ml per minute. You can pause and go through it. Osmolality in serum. In urine, albumin in 24-hour urine in male, in female, and in children. Microalbumin is less than 30 milligrams per day, while protein is between 0 to 0.1 gram per day. When all these are raised, then there is serious problem like glomerulonephritis. With this, I've come to the end of this short presentation on the common figures when it comes to renal system and laboratory investigation. Remember, each lab will produce their figures, but they will give the range. The figures will be different because of different methods and different gadgets used. Thanks for listening. Please remember to subscribe to my channel. I appreciate it.